the slope field or the 13-minute video where I actually work some other problems for you. But certainly if you still need clarification, I do want to answer that. So I won't be like, oh my gosh, watch the video, okay? So if you've done it and you're like, I still feel shaky about what's happening. Like for instance, I've had a few people come by and want to work more on the part where if and when you run into logarithms. When you separate variables, don't always think you're going to run into logarithms. Sometimes you do, sometimes you don't. There was one that I ran into a circle, if you saw that, okay? Like for instance this. I'll come back, that's just a reminder for me. So if you had y prime equals 2x over y, you're not going to be able, I don't think, to undo that. Because you'd have to unthink the x and the y, and you'll see that you couldn't go back to your original y. So this is the beauty of separation of variables. Y prime can be translated, in this case, dy over dx. Okay? And then I can cross multiply. And I don't really care about cross multiplying. I care about separation of variables. In the video and a little bit in class the other day, and always and forever while we're talking about this, every time I say it, leave as much behind on the right hand side as you can. In fact, even if it was this, I wouldn't take the 2 with the y. Do you see you would be prone to do that? You'd be tempted. I wouldn't, because you may not know why right now, but you run into substitution that when you integrate, you just might forget to compensate for the fact that you had a 2y instead of a y. You know, things like that. So leave it on this side. Do you see how I would do that? I'd pull as little over to the left-hand side as I could, in my experience, okay? Then when I integrate, I get y squared over 2 is equal to x squared over 4 plus c. So I don't always have to run into a logarithm, okay? Then you'll be given, if you're given a point, they want you to find the specific or particular solution, you fill in your point. Notice this one is a squared, and you're usually not finished with this problem until you've somehow solved for y. So here I would have y squared equals x squared over 2 plus whatever you found for c when you filled in your point, okay? Does anybody know what picture this is going to make that would match a slope field I've probably already drawn?
So you would never change the, like you wouldn't multiply c by 2?
Oh, no. Why am I not multiplying c by 2? It's still a constant. There's no reason to have a 2c. I mean, it's just still a constant. Okay. Does anybody know what picture this is going to make? A hyperbola. Okay. Because when you put it on the same side, you're going to have a minus, aren't you? Not a plus. If you were my student, and even if you weren't, listen up. When you have one thing squared, it makes a curve for obvious reasons that you think about later. If you have two things squared, you have two curves going on. The x and the y are both curving, so they may circle up, okay? If it's plus, those two curves will come together into a circle or an ellipse. If it's minus, they'll repel each other. It'll be a hyperbola. It could be heavy on the x-axis, or it could be going off of the y-axis, okay? So one thing squared makes one of these parabolas. Two things squared plus pulls them together, minus sends them apart into one of these two things, okay? So, anyway, this would make a hyperbola. What's going to happen though, I still haven't solved for y. When I square root, I only get absolute value of y, so I get plus or minus the square root of x squared over 2 plus c. There was one in there that I did recently with the circle where this was a negative x squared on this side, which is fine because the constant could in a lot of situations, it still exists if the constant's big enough to override the minus under the square root. Let's keep moving. Which, by the way, well, I'm sorry, I ended up talking about too many things and confusing you. They don't mean for you to leave the plus or minus. They've given you information as to which part of it that they're looking for, okay? So for instance, if they had said that this was on the point, and also that it goes through the point, let me think of a point. Let's say they say 0, -4, okay? So when I sub that in to find C somewhere, like right here is usually where I do it. If I put in, oh, I don't think I wanted that.
It would just be -4.
Yeah, you're right, but let's work it. So I'm going to fill in -4 for y squared, and I get 16 over 2 is 8. X squared is 0 plus C. Why did I get C as 8? I thought I would get C as -4. If C is 8 and you fill in 0, I've done something wrong. If you put in 0 for X, you should get -4. If you put in 0 right here, if C is 8, you won't get -4 for Y. So what am I doing here? If I put in -4 squared is 16 over 2. What's happening? 0 and -4 should fit in any of these. 0. Oh, we're good. Okay. And Grace, this will go to your question. Okay. So anyway, it's okay right now. So C is 8 in this instance right here where I chose to solve it. Alright, so right here I put in C. Before I multiplied by 2. Okay? If I had put in the point y squared equals x squared over 2 plus C, if I put in 0, -4, I would have gotten a different C. But it all works out. Okay? So when you're doing your own problem, this makes more sense. So let me pause for a minute and say I haven't gone this far. I could, once I integrate, I could go in and fill in the point they give me right then. Or I could wait and fill it in later, and your C always works out with what we need. If I do it right now, I think I got C was 8. So I have y squared over 2 equals x squared over 4 plus 8. So I get y squared multiplied by 2 is 1/2 x squared plus 16. And then when I square root, and by the way, whenever you filled in the point, you all would have eventually gotten x squared plus 16. Okay? Then when I square root, I get plus or minus. Alright, why did I choose the minus? Because they gave me the point 0, -4, not 0, 4. Do y'all see the difference? So what's happening here with y squared over 2 minus x squared over 4 equals 8? A lot of review in all of these problems going all the way back to algebra and pre-cal. This makes a hyperbola because I have two things squared, but they're repelled from each other. Okay, they're not attracted, they're sent away from each other. If y comes first, that means that your hyperbola is going to be going off the y-axis and it would match whatever crazy looking slope field you got. Okay? But since if they drive me through anything down here, when I go to pick the particular solution, I want that one. Okay? All of that to say, separation of variables is really important. And to also say, if you have y prime, and you can just think backwards and do an antiderivative instead of feel like you're full on doing an integral, that's okay. But if you feel like you really need to integrate it, change your y prime to dy over dx and use separation of variables. Separation of variables is only if you use them a lot. It'll be a free response problem, probably with the slope field. But there's only 6, so I can't say that for sure. But lately, that's what's happened. Okay, so anyway, any questions on any of the homework? Always mark it when you're working it, girls. Mark it so you can go, I have a question on this one. Did I give you some numbers on 307?
Yes.
But I didn't do those on the video, did I?
No.
Did I give you
I have a question.
60s? Did I give you 67?
Yeah.
Okay. Did I do that on video? I can't remember.
No.
Okay. Let's look at 307.67. It still didn't give me extend page. Sorry. There we go. All right, so 307, number 67. All right, so the integral of x squared of x plus 6 dx. I also really like the problem where you just had like 85, 86, 87, 88. You said, this is what I'm going to do. This is what I'm going to do. This is what I'm going to do. You didn't have to work it out, but it helps you make decisions for things that look a lot alike, okay? Like, for instance, I would do something completely different for this than I would for this. On this one, I would use u substitution. Because if I let u be x squared plus 6, du is 2x dx, I can see I'm going to have the components. Hopefully a lot of y'all know on this one, I'm just going to divide it down and make that x plus 6 over x. I would do something completely different even though they look a lot alike. Alright, so on this one, another thing that I talked with some of you about is a lot of your homework problems lately, not a lot, a very few of your homework problems haven't required substitution at all. Like if you have the integral of the square root of x times x squared plus 3, you can try as long as you want anyway, and substitution wouldn't even work there. But nor would I even try it. I could just distribute it and use the power rule. Okay? If I just try that first, remember how I made a big deal about that. Try to simplify it first. On this one, I can't simplify it. Would y'all agree? It's a product rule. I can't undo it until I teach you integration by parts. In which case you might try integration by parts with this one day. We might pull this problem up again. Sometimes there are a couple different ways to work the problem. Okay? Right now, if you can't undo it, your only choice is substitution. Okay? So you would have to let u be x plus 6. And du is dx. And so I have the integral of the square root of u, but I can't all of a sudden introduce an x into the problem. I can't put a variable in. And so then I come up here and subtract u minus 6 equals x. And x is u minus 6, and dx is du. Then I would distribute. That's u to the first and u to the 1/2 is u to the 3/2 minus 6u to the 1/2 du. And then it's super easy. It's simple. Add 1, u to the 5/2 times 2/5 minus 6 u to the 3/2 times 2/3 plus c, and then fill back in for u. This cancels. That would give me 4. Okay, so any other specific questions on homework?
Can we maybe do on the worksheet 17C? After doing the textbook problems, I understood what we did. But can we just still maybe?
Before we do that, let's do something else I had planned for today, and then we'll revisit that. So if I don't revisit it, wave your hands wildly in the air. Okay. The reason I'm saying hold on is part of 17's problem may be that we haven't done a lot of intervals of
Yeah, I think that was the thing.
And so you're going to have a lot of homework on it. Remember this day was coming, okay? If you want to take the derivative of a logarithm, it'll have an expression and it'll have a base. Okay? When you take the derivative of it, you say 1 over u. Now it's time to learn it. I expect I can put this on any test now on a non-calculator card. Now it's time. Alright, I'll kind of let you skate through not knowing it, and I say that every time. I'm like, I'm going to make sure you practice on this. You got to know this now, okay? There's a ton of them on the AP exam. So you say 1 over the expression. While you're down there, you say ln of the base, and then you go back and take the derivative of u. I'll just call that u prime. Some books write it like this. Okay? I don't write it for you like that because I want you to always be thinking of the chain rule. Do you see how I take the derivative of the expression and then I go back and take the derivative of u? Okay? That's how you take derivatives of logarithms. If you want to take the derivative of an exponent, you'll have an expression with a variable in the exponent. That's called exponential. The variable has to be in the exponent. Do not fall for trying to bring down x and subtract 1. That won't work. The power rule only works if you know the power, like x cubed. Did y'all hear that really well, okay? All right, so what you do is you copy it down, and I've explained why both of these things happened before in first semester. If you don't remember, I drew graphs and talked about it, but let's keep moving. You copy it down, and then while you're there, you say ln of the base, and then the derivative of the exponent. I guess I could call that du. I kind of like that better, I'm sorry. Let's call this du. Derivative of u. Okay? So now once you've done that, all of a sudden, if you start to see 1 over u, all of a sudden you should be able to go backwards to where you came from. Okay? So watch this. If I have the integral of 1 over x cubed dx, can you integrate that, and how would you do it?
X to the negative x.
I don't know whose voice that was. X to the negative 3, Alana. So always remember this. This is the way you do it. You add 1 and get x to the negative 2 over negative 2 plus c. I would make this negative 1/2 2x squared plus c if I was looking for my answers list. So make it a power, right, is what Alana did. Make it a power. Make it easy for yourself. You can only integrate something super simple. So now, I've only shown one of you this. I don't remember who it was, but maybe it was Caroline. So now how are you going to integrate this? X to the negative 1. Oh, what does that give you? X to the 0 over 0. That's unfortunate. That's undefined, right? That's why I keep saying, well, it really doesn't apply here, but right now I can't use that rule. However, I know there's an answer because I know what an integral is. It's a summation tool. And there's definitely a graph of 1 over x. So I know it's got an answer, I just can't do it with the anti-power rule. Alright? However, once you've taken enough derivatives of logarithms, which you'll get to do for your homework over the weekend, once you take enough derivatives of logarithms, you realize, oh, I keep going 1 over, 1 over, 1 over, okay? So the antiderivative of 1 over x is ln x plus c. Because let's take the derivative using this rule of ln x. Y equals ln x. The derivative, dy over dx, you say 1 over blah. While you're down there, you say ln of the base. But what's the base if you're working with logarithm? This means the logarithm of x to the base e. That's shorthand for, I'm using base e, 2.718. So while I'm down there, I get ln what? E. And then you go back chain rule and take the derivative of x, which is 1. And so at some point, the person working calculus took a derivative and they got 1 over x. Now you had to have noticed that ever happened to be able to go back and take the antiderivative successfully. But now if I took the derivative and got, oh my gosh, I just got 1 over x, okay? So the antiderivative of that is ln x. Did y'all notice I'm doing an absolute value? And a lot of this semester I'm gonna go because it said so. It can come and go into the problem. When you integrate, you have to put it in. When you differentiate, it can disappear. Why is it there? It's there for this reason. I'll come back to that in a minute. Don't let me forget to come back to this slide. Y equals 1 over x looks like this. Okay, so ln x just looks like this. Now, the red matches the blue. Sometimes it's nice to superimpose a derivative over its graph. The slope right here is -1. I didn't really get that. And these slopes are, wait, something's wrong. Hang on. ln x does look like that. Oh, I'm doing it backwards. That's why. Sorry. The derivative of this is not ln x. The derivative of this, sorry, I was doing it backwards. I would just do the power rule. Make it -1x to the -2. Okay? So now that I've gone that far and messed it up, it might be good to talk about it. I can use it to our advantage. Then I'll go back and explain the absolute value. Okay. All right, so, sorry about that. This is not even what I wanted to do. But if I took the derivative of this, I would get -1 x to the -2 or -1 over x squared. Okay, I just took a derivative you've known for a long time. All right, x squared looks like this. It's an even graph. -1 over x squared then is going to look like this, which is a whole lot better if I'm going to superimpose it over here. They don't quite lie on top of each other. The slope here is -1. The slope here are negative, but they're getting closer to 0. The slopes back here are really high negative slopes, like -4. And doesn't the same thing happen over here, except for, whoa, hang on. Now I'm confusing myself. Oh, that's right. Okay, so these slopes are negative. They're very small negatives. This slope would be -1, and these slopes are bigger negatives. Do y'all see how that matches? The blue graph, if you could still see it, it's interesting. I guess I could say it's always decreasing, even though the right-hand side is higher than the left-hand side. Okay? But the slopes should all be negative. All right. I didn't even mean to go that way, but I felt like I need to clear it up since I started backwards. All right, so let's look at if I just do ln x. All right, we just talked about the derivative of that is 1 over x. All right, so ln x does look like this. Okay, 1 over x looks like this. It's a degenerate hyperbola, is what that's called. The axis has been rotated, and y'all see a hyperbola going like this, okay? It's also many times written as just x times y equals a number. And it'll make a little, it's a little equation that makes a good hyperbola. All right, back to this. This is increasing, so what should its slope be? Positive? They start out steep and end up close to 0. So check mark, feel good about that, okay? But what about this? If I'm integrating 1 over x, I can't really say it's ln x. I don't know which piece I'm talking about. Do y'all see what I mean? But what did I tell you? If you integrate 1 over x, we say ln of the absolute value of x plus c, okay? Because over here, if I take the absolute value, do you see it allows these numbers to come in? You may not. Let me talk about that. ln of 1 is 0. ln of 2 is 0.693. I'm proud to say that I don't know what ln of 3 is. If I did, I'd be a little bit worried about myself, but it's something a little bit bigger, okay? What if I have ln of 1/2? Let's do our logarithm rules. That gives me ln 1 minus ln 2. Remember in your algebra, hopefully. If logarithms are divided, you can subtract them. ln 1 is 0, so I get negative ln 2. So at 1/2, do you see why all of a sudden these start being negative? Logarithms are exponents. Logarithms find you exponents, okay? So as this number gets bigger, these numbers get bigger, but not much bigger. Does anybody know why? If logarithms are exponents, why aren't they getting much bigger? An exponent packs a lot of power, doesn't it? And so to make a bigger number, you don't need a much bigger exponent. Like for instance, if I have 3 to the first is 3, to get 27, I don't need much to make that happen, do I? In terms of the exponent I'm looking for, don't I just need a 3? I don't need anything much to make a big old number, okay? So as x gets to be a big old number, you don't need much exponent to happen. Now, what you are never allowed to have a negative next to the word logarithm. That doesn't make any sense. If I say the logarithm of negative 9 to the base 3, 3 to what power is going to give me negative 9? That doesn't make any sense. I can't even do that. Do y'all see what I mean? Okay? However, what if I put an absolute value in? Then it does allow negative 1, negative 2, because what does it turn it into right at first? A positive? Okay, so I'm sorry. There was a lot of information about ln of the absolute value of x. But as soon as I put the absolute value on it, it makes it an even graph, and so it's symmetric over the y-axis. In addition to all that other stuff I told you. Are y'all okay with this picture? Okay, so really when I integrate 1 over x, I should be able to compensate for what 1 over x is. How many parts of 1 over x do you see? It's a piecewise graph. There's 2 parts. So I can't say I integrate 1 over x and I just get sweet little ln x. I don't. What happens here is if this is the derivative, what should its graph be doing? This derivative is always negative. So its original, not its graph, its original, its integral, its antiderivative should always be doing what? Decreasing. Is that what's happening over here? Okay. And the slope should mirror whatever's happening over here, but in the opposite direction. So, I don't know if you grabbed all of that, that's why. Now you're just going to do it. But when you integrate 1 over x, you always have to go back to go, I need to compensate for both of those pieces. I'll make a decision later on about which one I might want. Okay? But if you take the derivative of ln x, you just go back to this and you're safe. So you don't need the absolute value. Okay? The derivative of ln x gives you the whole thing 1 over x. It's when I'm going backwards that I have to put the absolute value in. Hopefully that at least gives you some sort of concrete reason to do it. Okay? All right, now let's go back to this important slide. In fact, let's make a new slide for this. All right, so these are facts that you need to know and that you need to start practicing. If you have y equals the logarithm of u to the base a, and y equals a to the u, an exponent or a logarithm, to take the derivative of the logarithm, you say 1 over log, ln of the base, times the derivative of the expression. To do an exponent, you copy it down, which I explained another day. I'm not going to go into it again. ln a times the derivative of u. I don't put it in parentheses, but anyway. So now when I integrate 1 over u du, I realize that's ln u plus c. But that's the value on there. You just saw a picture of it. Hopefully that helps. Now this is a big, huge pause. Notice I'm not finished. This is a big, huge pause. Something happens with all students' brains. It won't be just you, but it will be you, and I'm going to try to prevent it from happening. Once you get 1 over u is ln u, you tend to think every 1 over something is an ln something, and that answer choice will be sitting there. Going back to how Alana answered this for me earlier, this was easy before, and you would never miss it. Right here, 1 is like, make it x to the negative 3, add 1. You'd never miss it, okay? But all of a sudden, you couldn't do this one, right? Because you got x to the 0 over 0, all right? Once I teach this, or any teacher in the whole wide world, because you'll see it when I give you practice AP problems, once I teach that, people think every 1 over is an ln. So an answer choice will be sitting there for the interval of this will be ln x cubed of some sort. No, it's only 1 over x to the first. All the other ones are powers. Big deal, okay? All right, so now let's go back to this slide that gives you just facts. By the way, these are all on your study sheet. And then what if you want to integrate an exponential equation? You copy it down, and since you're going backwards, you say over ln a plus c. If you're taking the derivative of a to the u, you say times ln a. So let me scroll down. You need to know these desperately. These will now be required. And like I said, I've been honest with you, may have looked at even help people with their AP Calculus AB homework, and if you got to these, it's just way earlier in their book. So you may have looked at it and gone, oh, I'm not very good at that. We're going to get rid of that. Okay, so let's get some of your homework done. I'm going to go in and do this slide before I forget. I've told you this before, but you know, sometimes you have to hear funny, weird incidences again. It's really weird, that wasn't it? Okay, isolated kind. I think some of y'all remember what this is. 7 logarithm of 10 to the base 7. Like, I couldn't work that out, but that could be on a non-calculator part of like an SAT. What is that? 10, okay? You can verify it with something like 5 logarithm 125 to the base 5. It's a very redundant question. It's like inverse functions. Exponents and logarithms are inverses of each other is why this is happening, okay? Isn't the answer to that 3? And then, so you're like, hey, go find me an exponent you raise 5 to get 125. When you find it, let's raise 5 to it. You're just going around in a circle. Would you verify that that is 125? Okay. All right. So if I have E3 ln x squared, this was actually a multiple choice question on an AP exam years ago. You might see it today, okay, or not today, but when you take it this year. And you're going, well, I copy it down. I copy it down, and while I'm there, I say ln of the base, but that's just 1. And then the derivative of the exponent is, well, I'm going to have to do the chain rule, so I bring my 3 down, and I get 6 ln x to the first, and then I go back and take the derivative of ln x, which is 1 over x. And you're happy that you learned how to do this. Sorry, all right, so you're happy that you learned how to do this. And I don't know where that negative came from, what just happened here. Okay, so I did the other slide, copied it down, ln of the base, the derivative of the exponent, okay? And then you go looking for your answer choices, and they're all sweet little things like x squared. Like, oh dang, okay? Like, or something stronger maybe. Like, oh my gosh, well maybe I'll just guess. Always simplify on the front end if you can. Be highly suspicious once you start seeing them. All this ELN or exponents with logarithms. So first I'm going to use my algebra, and I'm going to move this 3 up here, and I get ln x to the 6. I'd say you want to do that anyway. Get really used to like unpacking and packing your logarithm rules. Okay? And now, isn't this e logarithm of x to the 6 to the base e? So they were trying to see if you just knew that was simply x to the 6. And the derivative is 6x to the 5th. Which that would be too if I figured out a way to unpack that. That would be 6x to the 5th. At least see a 6 in here. That's 1. This right here, if I move this up, would be all of this. Remember, we just decided would be x to the 6th. So this answer I have right here is x to the 6th times 6 times 1 over x. I did get the derivative right. Isn't that 6x to the 5th? But which one would you rather do? Okay? So I'm just trying to make you aware of things, all right? Okay. So you'll have a little bit of homework just on algebra, just some of your homeworks that I don't know if we'll look at together in here, but some of them will be just going back over some of the logarithm rules, which I'm sure you'll be thankful for, okay? I mean, maybe not thankful for, but I'm sure you agree that we all need. I don't, but you do. Okay. Well, wouldn't it be scary if I did need that? That would be frightening. Let's see. Where did that slide go with all the numbers on it? I wrote down all the numbers I needed to go over. There it is. Okay. All right. Let me do this first. All right. This is page 307, number 89. And girls, this is, these ones are not technically going to be listed in your homework. These are just examples I needed to do. So 307, number 89. All right, so we have dy over dx equals 2x over the square root of 2x squared minus 1. And the graph of the original function is actually given to us, but I'm not going to draw that right now. I'm just going to find the original. I'm going to solve for y. So this is where separation of variables comes in. You want all of your x's or whatever variable you're working with, follow your variable. And I don't even have any y's to move to this side. Separation of variables. All right, then I'm going to integrate. What's the antiderivative of dy? That's right, what is it? Y. Because it's like 1, follow your variable. Here I'm going to let u be 2x squared minus 1 after I have already evaluated if I can simplify it. Okay? Du, I feel like it's going to work pretty well. I get 4x dx. So I'm going to say 1/4 du equals x dx. These problems, when you do separation of variables, you'll be able to do them, so you get a ton of them. But almost every year on free response, there's at least one that's worth like 5 or 6 of the 9 points. And you're just racking up points by taking step after step. You get a point for separating your variables. You get a point for saying plus C later on. You get a point for filling in your point that they gave you. By the way, our point is 5/4. So rack up those points, okay? All right, so this is equal to the integral of 1 over the square root of u, and then x dx is 1/4 du. What do you see that's still left in there? X dx is 1/4 du. I have the square root of u. I've accounted for everything except for the what? The 2. So I can just put it right here. And mentally I had already moved it out. Okay? Now this is not a logarithm. So this gives me 1/2. This is the integral of u to the negative 1/2. So I add 1 and get u to the 1/2 divided by 1/2 or times 2 plus c. And I'm not going to finish this problem, but do y'all see how I'd fill back in for u? And it's already solved for a while. Like I don't even have an issue here. Let's see what I had on 420. By the way, the ones on even, odd, and neither, if it's even and you're going from like -5 to 5, you want to double it and go from 0 to 5. If it's odd and it's going from -5 to 5, you don't want to do anything because that's 0. And so you may have to go back and think about those ones in the 80s. Some of you are nodding your head and some of you are like, okay. So, 420. Or come talk to me about it. I talked to a couple of y'all about it yesterday afternoon. I'll be glad to explain it. 429. All right, this is number 9 on 420. All right, number 9 on 420 is 1 plus x squared y prime minus 2xy equals 0. And our job here is to solve the differential equation. I'm trying to get used to the terminology, the language. It could say solve the differential equation means you want to know why. Find the particular solution means not only do you want to know why, you've still got a point to plug in, you're not going to have just a plus c. So I got a lot of separation of variables to do here, which is why I didn't assign this for homework. I just wanted to model this for you. And so I have 1 plus x squared dy over dx equals 2xy. So I have dy over dx is equal to 2xy over 1 plus x squared. What do I still need to move? Grace?
The y.
The y. And I might as well just take it. So I'm going to have 1 over y dy equals 2x over 1 plus x squared dx. Oh, sorry, I got too many dx's in here. Did y'all see at some point I need to move that over there? Separate my differentials. These are differentials. Then are y'all okay so far? Mm-hmm. So it's algebra to this degree. Then I'm going to integrate both sides. And the right-hand side is going to require substitution. Now, what is the antiderivative of 1 over y? ln y. And this side is going to be u is equal to 1 plus x squared. du is a perfect fit, right? 2x dx. By the way, girls, if that was upside down, I would just simplify it. Okay? So this is the integral of 1 over u, this is u, and what is 2x dx? I see the whole thing, is du. Wow. You'll see some people write it like this, du over u, that's fine. I just like for you to see the 1 over u in your face, okay? So I'll write it this way. So now I have, you'll be kind of glad I did this one for you. 1 over u is ln u. Now I'm going to fill back in for you. Now when they say solve the differential equation, find the particular solution, they mean solve for y. So this is ln y equals ln of 1 plus x squared plus c. Why didn't I put absolute value on 1 plus x squared if I'm supposed to be doing that? It's always positive anyway. I mean, you could put it there, it's not going to hurt anything, but I don't really need it aggravating my problems. Now, one thing I like for you to do is just keep on walking with what I've taught you how to do. I will not let you walk in that exam, or really one of my tests, without me having giving you done things. Okay, granted, very fast and a lot, but still. You may not like this, because it got all this ln stuff in it, but you know what to do to solve for y. So now I'm going to do my little cycle. This is base E. So I'm going to say E to all that junk equals y. This will happen to you. All right, so I have E to the ln 1 plus x squared plus c equals y. And in some ways right now, Celine, I'm answering your question on 17. Okay? And almost all of your questions in here are algebra questions. at this point, which is normal. Okay, that's a mess. So there's a lot of reason why I've done everything I've done today to get to this point. Alright, this I'm going to rewrite as e to the ln 1 plus x squared e to the c. What is x to the 3 and x to the 5th is x to the 8th. What is x to the a and x to the b?
X to the A plus B.
Alright, so you're used to going this direction with it, but you can also go that direction. If you have exponents that are added, that must have meant that they had the same base and they were multiplied. So did y'all see how I got from this step to that step? I see these added bases, added exponents. Those are subtracted. I would write e to the blah over e to the blah. Okay? Now, you've heard it in the video, most of you, but let's talk about it together in person. It's kind of like what Grace asked. There's no reason to say 2c. You could, it wouldn't have hurt anything. You would still end up with a little bit different work with the same exact equation, okay? But why call it 2c? Because you don't even know what the constant is anyway, we just call it c. E is 2.718. So 2.718 to some power is just still some other constant. When I get here, I'm just gonna call that c. You don't have to, you can keep it e to the c. I've had some students do it before. And it'll all work out with you, but most of y'all don't want that exponent in there anymore. Any questions? So now I have y is equal to e to the c is c, e to the ln 1 plus x squared. That's not my final answer. By the way, I have no point to fill in here. So we're finding the general solution. What's e to the ln 1 plus x squared? You gotta see that. Isn't that like just the same thing we just did with 7 logarithm 10 to the base 7? Okay? So whenever you run into e to the ln u, that fits that rule, that's just u. Okay? Alright, what other numbers do I need to do? Here's the answer. And without a point, I'm not going to know what C is. Let me see if I want to do these others right now. 11. Oh. Okay, on 11. 11 says some wording that you're just going to need to be able to recognize. All right, while I do this one, I'm going to have Caitlin read it to me. So read me number 11 and watch me write as she reads, like I do with related rate problems. All right, I'll make you pause every now and then, Caitlin. Everybody watch while she reads 11. Okay.
The rate of Q with respect to T is inversely proportional.
Wait, I'm sorry, Q? The rate of change of Q
Yeah,
with respect to T.
is inversely proportional to the square of T.
All right, she read me the words inversely proportional to the square of T, not the square root of T. Be careful that you read it correctly, okay? So I'm going to do this. Inversely proportional to the square of T. And if it's a proportion means it always equals some constant. We don't know what that is. Read me number 12.
The rate of change of Q with respect to T is proportional to 25 minus T.
Okay. It just said proportional. It didn't say inversely or directly. So do you know what it means by default? If they don't say, if they just say it's proportional by default, everybody means directly. Okay? So it might even say the word directly. If it's directly, I divide. Okay? Let's talk about the difference in direct proportions and inverse proportions. Okay? A direct proportion, I divide. Like boys to girls. Okay? If we were gonna start accepting boys in the Marymount, then we might want a certain ratio of boys to girls. We might want it to be a same ratio, okay? So, or if we just start accepting girls. So anyway, if I have 4 boys and 4 girls that I've accepted, and I'm like, well, you know what, I want a bigger class than that. So I'm gonna let 16 boys come in. If I get more boys, I have to have more girls, okay? A 1-to-1 ratio is not really a great idea. So suppose we're just getting started with this, which I'm not proposing, this is fine, I'll go slow. But suppose we said we want it to be 1 to 3, okay? You might even look at some proportions, and when you're looking at colleges of certain things, whether it's ethnicity or gender or whatever, okay? That doesn't mean there's only 1 boy and 3 girls, right? So proportion is a constant proportionality. So if I want to maintain that ratio of people I'm accepting to something, okay? So if I have 30 girls, I'm going to have 10 boys. 60 girls, so why is it a direct proportion? That's because more is more, and if I get less is less, right? It's directly proportional. I push my accelerator down more, I go faster. It's a direct proportion. An inverse proportion, I multiply. Like suppose this is the area of a rectangle. 2 times 4 gives me 8. Girls, listen, what if I don't like that rectangle? What if I want to make this 4, then what does this have to be? 2. So if I make x 2 and y is 4, I get 8. What if I increase x, what do I have to do with y? Decrease it. Okay? What if I decrease x? What do I have to do with y? Do y'all see more is less and less is more? So when Caitlin's reading words to me, the rate of change of Q with respect to T is inversely proportional to whatever constant, or the rate of change is directly proportional to whatever constant. Then you go forward from there with separation of variables. Then you move things around and find Q. Do y'all see what I mean? You'll see some of those, okay? So now let me do this. Let's go to this. All right, so I'm doing page 340. Oh, by the way, please notice it says every other line, okay? Circle them in your book, make sure you don't do too much. All right, every other line. So number 1. You probably don't want me to do number 1. You probably thought you could do number 1. So let me pick another.
Let's do 41.
Let's jump
do
to
the
41.
hardest ones.
All right.
Yeah.
Anna, why don't you circle every other, well, there's certain ones I want to do. Sorry. Okay, so I'm going to pick, you're not going to pick. Alright, I am doing number 5. Alright, so if you want to take notes, you can, when I'm doing a homework check, I'll know that you wrote down number 5, or you can look at it on the video if you want to later. Alright, so this is the integral of 1 over 2x plus 5 dx. Those are something else I need to do. I'll probably have to shove it to the next class. Okay, so anyway, I'm trying to think of a way to simplify that. I can't think of any way to simplify it. So I'm going to let u, right, Morgan, be 2x plus 5. du is 2x 2 dx, which makes me happy because it looks like it's going to be a good fit. Now be careful, don't just fall for 1 over u. They'll have that waiting on you. Make sure you do substitution. Girls, you can only integrate something simple. Don't I keep telling you that? Because the things I see you fall for, okay? Not you personally, but my students overall. Or myself, okay? I mean, the only thing you can integrate, if you got any business trying, is 1 over x or 1 over u. Nothing else. Okay, so that's why I let u be 2x plus 5. So now this gives me the integral of 1 over 2x plus 5, and dx is 1/2 du. So this is 1/2 ln u plus c. And that's the answer, okay? All right, 5, I'm going to number 9. All right, number 9 is the integral of 4x cubed plus 3 over x to the 4th plus 3x. If the top exponent was bigger than the bottom, I would do long division every time. Or see if I could just simplify it one thing over the other. If the top exponent is bigger than the bottom, okay? But I can't divide this because the bottom exponent is bigger than the top. So they have kind of rigged this one up. I'm not even going to finish it. I'm going to let u be x to the 4th plus 3x. And you see it's going to be a perfect fit for 1 over u. du is going to be 4x cubed plus 3. That's going to be just a perfect fit, okay? All right, so that was 9. All right, now I'm on 17, which I think is one of your problems. I'll double check, because you only want your problems, I'm sure. Okay, 17. Seventeen is the integral. Let me double check. 1 skip 3, 5 skip 7, 9 skip 11, 13. X cubed minus 3x squared plus 5 over x minus 3. Okay? Girls, do you see here? In fact, even if you try it, use substitution, it wouldn't work either way, anything you do. But I would jump right to long division. So I'm going to make this x cubed minus 3x squared plus 0x plus 5 divided by x minus 3. I'm going to multiply by x squared. Gives me x cubed minus 3x squared. I subtract. These cancel. And so I bring down 0x plus 5. So I multiply by 0. And so here's my answer. I have the integral of this divisor, the dividend becomes x squared plus, my remainder is 5 over x minus 3. All right, did everybody follow that?
Yeah.
Okay, so my x squared, as far as I could go with this, and some of them you might have more, and I just have that constant 5, I can't divide into that. So our remainder is 5 over the dividend, or divisor, whatever those words are. Okay, quotient. This one's quotient up here. All right, so anyway. Then I'm not going to finish this, you'll finish it, but that part you can integrate and this part becomes some form of 1 over u. Okay? All right, and you can see these go pretty fast, they're just thought provoking. Okay, so now look at this. I haven't posted assignments yet, so I'll show you what's on there. I'll just make sure I post what I really want you to do. By the way, let me say this, the quiz on slope fields, if you can do that worksheet, you've got video with it, you've got the answers. I'll pick a few problems that are similar to the ones in the worksheet. Obviously, we can do that, but it doesn't take the entire class, and I can't have that, but they'll be draw a slope. There'll probably just be one free response, actually. I haven't formulated it yet. But it would be like, probably end up being like 17 and 18. Celine, hopefully what I've said today helped you with
Yeah,
17.
I get it.
And then you can watch it again.
It was just the fact that like I just didn't know that like the LM part and E to the C to like C times E to whatever that.
Don't think when you separate your variables, you're always gonna need a logarithm, okay? So if you wanted to study one thing, you could study 17 and 18 because that was the culmination of the whole worksheet. Okay? And 17 and 18 would obviously be at the end of the video. Hey girls, look at this. You'll run into some of these on your homework, and I've got 1 minute. Okay, so we'll see where we get with this. I'll just introduce it. I'll probably take these off your homework. So I'll do the good olds. Let me show you what's coming just real quickly. These are frightening. Like, why don't I know these? Because don't they look easy? And you're thinking, whoa, why don't I know these? Why do you know sine and cosine? Because you've taken the derivatives and gotten those before. Okay? I've shown you this one time and I'll continue to show you. This one is ln, negative ln cosine x plus c. Because now you're prepared to check that. Let's take the derivative. You would say the negative of 1 over cosine. The derivative of cosine is negative sine. And the derivative of c is 0. So I just took the derivative of this, and I got tangents. Now I can go backwards. All of these are going to have logarithms in them.
Memorize.
And you'll memorize them.
That's very fun.
Okay? And I'll hold off, but you won't have, I'll cut down the homework. Okay?
Thank you.
Bye, girls. So do not look at the syllabus, look at the assignments. Emily.